Welcome to this demonstration of quality of service monitoring xApp. In this demo, we simulated a 5G network consisting of 19 users distributed across 4 slices and each with service characteristics and performance requirements. If you go into the slices and services, this is a VRWave rig tester, basically an emulator. We have 4 slices, 2 for EMBB users, one is for voice, another one is for video, and we have allocated certain percentage at this point of time. We have 2 TSN users slices as well. One is for the static user, that is URLCC UE, and another one is for the drones, basically, and for URLCC underscore drone. And again, we have given 10% of PRBs, maximum PRBs right now. If you go into the user's configuration, as I said, there are 4 types of users. We have one pedestrian voice, which is basically 10 users, and all these users allocated to one macro cell, that is S5 at this point of time. They have very low target throughput, that is 1 megabits per second. Whereas if you go for the TSN users, they are more stringent requirements. We have GBR as well, which is 3, and target throughput as well as 3. We have drones which are flying around a simulation with different altitude and the speed, basically. Right, if you go into the live charts at this point in time, this is a running simulation at this point in time. This is how it looks. If I can show you the drone pattern, we can look into a drone 13. Which is basically, that's a trajectory of it going from this corner and all the way, basically. Right, what our main goal for quality of service xApp is to continuously collect the real data from our macro cells and analyze any metrics such as throughput or SNR or channel quality. And each user's performance is evaluated against its service target, ensuring that SLA has been met in real time. Now coming back to over here on our left side of the screen where our Python scripts basically are working. What basically we are doing here is we start with run a simulation. At this point we are running RSG 631. We try to connect first via Wave emulator and we try to grab all the data, and that's basically fetching reports is what it's showing. Right now we have 3 reports, cell, UE report and UE flow report, which basically gives us an OK test if it has been connected. Then later on, we process the files, we create a UE view. Basically, what we are trying to do in this step is we do a several process check, like removing any duplication, alignment in the timestamps, or cleaning an incomplete entries, basically. Once that's been done, it has been neat and clean. We have our xApp, quality of service xApp, starts detecting any violation that has happened. So the below table UE QoS violations basically tells you that there are 19 users, as I said, and we are showing their slices they're associated with, what kind of cell they are connected with right now, the priority they're associated with. The throughput is achieved throughput at this point of time when the simulations are running. The gap basically gives us the difference between what was the target throughput we have established at the beginning and what has been achieved in the simulation. Our quality of service xApp basically starts detecting any violations, and if it has any of this condition has been satisfied, it says it has breach has been happened, and what type of breaching has happened, it basically noticed down. At this point of time, we have only throughput as a breaching type, so that's why you can only see throughputs. This is just an example. I'm going to run a live example at this point of time. So we have run our Python script. This is the simulation for RSG 3631, as you can see on the right hand side. The violation has been detected by our TSN U3 of our TSN users, and those are throughputs basically. Our xApp also understands if any persistent violations are happening, so it keeps record of which users has been violated more than once or twice. Based on that, it again also compute and see that if there is any slice impact has been happened and which slice got impacted very high or low, at what degree basically. Once all this information is gathered, our xApp basically triggers the next xApp, that is network slicing in this case scenario, where we give users a reallocation of the resources. Now, if you can see over here, we had 3 of the TSN users which were getting violated. Once our network slicing xApps has been triggered, we were able to save 3 of them, and only 1 is basically right now again in breach position. And our xApp will be basically right now figured out how to save another one as well. We can see each time the network xApp has been activated, you can see there is an increase in the resources. The green line indicate URCC user for TSN static users basically. And we have been increasing slowly, gradually, the amount of resources that needs to be increased to satisfy any SLAs, any breaching that has been happening. Our drones has been satisfied, so it's doing pretty good at this point of time, but there's one of the users that is still getting breached. Right, as you can see over here, our network slicing xApp basically satisfied all the TSN users. There's no more breaching happening, and it gives us a command statement saying that no URCC throughput SLA has been breached. And that helps us 2 of the xApps right now, that's quality of service as well as the network slicing. Thank you.